Um, so before we go into the theory, let's review what the RSA encryption is. So RSA encryption is a asymmetric kind of encryption, which means that um, there are two keys. One is the public key and the other one is private key. So the public key is something that you publish to the public, to the world, so that anyone who wants to send a message to you can send a message to you in private, while the public private key is the key that you keep to yourself. You don't share it with anyone. Otherwise, any message that is encrypted that was supposed to be read by you will be read by someone who also has the um, private key. Okay, so for RSA, um, we have a two prime numbers, so very large prime numbers that we multiply to get a number, a composite number n. Okay, so P and Q, they are what you call the prime numbers, and n is their product. And there is another number C, which we use in order to encode the message. Okay, so the set of numbers n and c is called the public key, and that this is the one which you publish to the world, so that anyone like Bob can send you an encrypted message. So if the message is A, if the message is represented by a number A, then you get the power of A raised to the C, and then get the remainder. Okay, so the remainder is the remainder when you divide it by PQ. Okay, PQ is also N. So when you divide it, get the remainder, that is your B. Okay. So now when the okay, someone joined. See, actually I cannot see who joined.
It's Sir Ron, sir.
See who joined. Asher.
Hello, sir. It's Sir Ron. Hello, Sir Ron.
Hello, 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 hello.
Oh, hey Ron.
Yeah, yeah,
I'm glad you can make it.
yeah, yeah.
We were just
Yeah, yeah. Go ahead.
Hey Ron.
Yeah.
Hi.
Hi,
So
hi, hi.
we were just reviewing
Uh-huh.
the RSA, and then yeah. So now we are now in the part where we yeah, where we
Yes.
discuss the private key. So if you have for example, if you are the owner of the private key and someone sends an encrypted message to you in the form of letter B, okay, what you'll do is to raise it to the power D modulo modulo PQ, sorry, modulo P minus 1 Q minus 1. Okay, so sorry, I'm sorry about that.
No worries,
So
no worries.
modulo P times Q or modulo N, and you'll get A. Okay, so guys, so it's quite easy to be to it's quite easy to be confused by these notations now. So that's why first of all, I encourage you to to interrupt me anytime. Okay, if you don't understand. And also, I'm going to give you some, I know, things to, uh, what you call this, I'm going to point you to things that you need to understand. Okay, so later I'll show you that. Okay, now we'll go to the next slide, which is the review of period finding. So if you are someone, of course, if you don't know the private key, then there is still a way for you to crack, okay, to crack the RSA encryption, and that is by finding the period, because the only thing that is available to you are the public key, and also the actually that's the only one. That's the only one that's available to you. So you have to derive, okay, what is known as the period in order for you to decrypt the the message now. So the period, what is this period? Okay, the period is the smallest integer that satisfies this equation. No? So b raised to the r modulo n is equal to 1. No? So ibig sabihin yan, if you raise b to the power r and then divide it by n and get the remainder, okay, the remainder is what we're after. And if the remainder is equal to 1, then you got your period. Okay, so that's the period. Okay, next. So once you get your period, what you'll do is to get the inverse of this period modulo r. No? So notice that our modulo has now changed. No? So before it was n, and now it's, and then when it became p1, p minus 1, q minus 1, and now it became modulo r. Okay, so I'm going to show you what why it is the way it is. Okay, so once you get the inverse of C, okay, C is the cipher. C is the what you call this is the coding number. Okay, so which is the exponent that you use to encrypt something. So C, you get the inverse of that modulo R, which is which we signify as D prime. Once you are able to find D prime, what you can do is just raise B. Okay, B is your ciphertext. Okay, it's the encrypted text. You raise that to the power D prime, and you get your A back. Okay, so what's the objective of us learning this? No, yeah, okay, guys. So you know, it's really hard to appreciate things if you don't know what's happening. No? But sometimes you can take the another route, no, which you just take it by faith. Okay, you take it by faith that it is how the way it works is, you know, you're given an algorithm and someone will tell you, okay, this thing will work, and you don't know what's happening. Sometimes you just take it by faith so that you can move on. No? For example, to doing Shor's algorithm. But sometimes if you don't, that's why this course is optional. That this session is optional. So if you take it by faith that RSA works without trying to understand it, that's also okay. But this one is really for those who are interested in knowing why it works. Okay, so that's why our objective now is we need to understand why is D able to decrypt the ciphertext B. Okay, so and then D, D is the private key. So why is it that when we compute for the private key, we use the modulo P minus 1, Q minus 1, no? And not P times Q, okay? Because P times Q is our N, di ba? That's why if you are given N, which is the modulo, and since N is a very big number, it is so hard for it's so hard for you to get P and Q. Because why do you need to get P and Q? Because if you know P and Q, then you can compute P minus 1 and Q minus 1. Okay? And once you know P minus 1 and Q minus 1, and for example, you know D, you can then compute the sorry, and you know C actually, because C is part of the public key, no? So if you know P minus 1 and Q minus 1, and since C is a given, because it is the one that is used in the encryption, then you can compute for letter D, for the number D, okay? Using the an algorithm called Euclidean algorithm. And once you get that, you can you can then decrypt now. But it is really hard to get P and Q. Okay, so but there's another way, no, which is using the what you call this, the period. Okay, the period R. So which brings us to point number 3. Okay, why is D prime computed in modulo R? No, so D prime is another inverse, no, which we compute in modulo R. It is the inverse of C. Okay, so if okay, let me annotate this. Okay, how do I do this? So this one here refers to D. Okay, D is the private key. Private key. Okay, private key, and this one refers to refers also to, well, D is the inverse of C, okay, modulo this one, okay, but this one is the inverse of C modulo R, okay. So the question is why is it like that, and why is it able to decrypt the ciphertext B? Okay, so let's continue. Okay. Okay, guys, now, so we are going to talk about group theory. Okay. So this is just enough group theory for you to appreciate RSA. Okay, so we don't go into deep group theory. But group theory is a very ano siya, no? It's a very interesting subject in mathematics, because it is useful in so many things. No, it cuts across both math and physics. No? So, for example, there was a time where people were very excited, no, to be able to solve the cubic equation. No? So so there was this mga Italian sila, no, si ano forgot the name, I think it's Tartaglia, who so there was this guy who solved the cubic equation, no? And then so during that time there were two of these guys who were who were trying to get to the first person to publish the solution to the quartic equation, cubic equation. And then the other one, he was the one who solved the quartic equation. When you say quartic equation, di ba meron tayong quadratic, no? X squared, no? X squared plus AB plus C. So yung cubic is x cubed naman, no? Quartic is x to the fourth. So when people were able to solve the quadratic, the cubic, and the quartic, and then they were now excited to who can solve the quintic equation, no? X to the fifth. And it took so many years, no? It took so many years, and no one was able to answer, get the express the answer in terms of yung mga radicals, no? Yung mga cube root, square root, fourth root. And then one guy by the name of Hendrik Abels, he's a Norwegian mathematician, no? He was he invented the branch of mathematics called group theory, no? And he used group theory. So there were two of them actually. One is Abels and the other one is Galois, Évariste Galois. And these two guys, you know, they're very young people. No, Abels was only 26 years old, no, when he died of tuberculosis. Imagine. And Évariste Galois, who is a romantic guy, you know, he died of a jewel, no, love jewel, in France, no, the age of 31. So they invented this group theory, and group theory is the one which shows that you cannot solve the quintic equation using radicals, no, yung mga square root, cube root. You cannot solve it, no. There's no solution, and that's the
Question,
power
sir.
of group theory in terms of mathematics, no. Pero sa physics, it's also very powerful, no, because in physics, there was this, you know, the quarks, diba? If you are familiar with or you've heard of, what's that? Are you able to hear me?
Yes, sir. Hello, sir. A question po,
Okay.
sir.
Ron? Hello, guys.
Yeah.
Hello.
I think it's lagging in Sir Bob's
Hello.
end.
Yeah. Okay. Question. What's your question?
Hello, sir. A question. So,
Oh
it states
no.
there that like x to the fifth can't be able to solve. So, anything above or
Hello.
beyond
This.
the x to the fifth can't be like x to the sixth, x to the seventh can't be solved. So, x to the fifth is just like the barrier where everything can be solved using square root and things like that, sir.
I don't know. I don't know. Yeah. I don't know. The only thing I know is that the quintic equation was proved to be non-solvable using radicals.
Okay, sir.
Okay.
Thank you,
Are you
sir.
able to hear me? Okay. So let's go back. So yun nga, group theory is also used in physics, no? Like for example, this we all know about atoms, right? We know that the atom is composed of a nucleus and a electron and electrons, no? And then the nucleus is composed of okay, protons, no? And so actually I forgot, no? I think there's also a neutron, but beyond that, there's also another interesting part of physics called particle physics, for which you study other fundamental particles like quarks, no? Quarks. Now, itong mga quarks na to, they are actually predicted, no? Before anyone saw them, they were already predicted by the theory. And the theory that was able to predict it, so particle physics, used group theory, no? About group theory is the study of symmetries, no? So anyway, that's the introduction to group theory. Um, when a certain mathematical theory has only very small number of assumptions, anything that the theory uh, will say is quite powerful. No? So, for example, in 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 the mathematics of calculus, okay, so mathematics of calculus um, is based on a concept of continuity. No? Now, the concept of continuity is actually there's a mathematics to that. It's called topology, and topology, which is the which in turn is based on the concept of set theory. So if you're able to, if you have a theorem in set theory, that will also apply to the calculus. And if you have a theorem in topology, that will also apply to the calculus. If you have a theorem in calculus, doesn't mean it applies to the reverse now. Because calculus is a very more specific, okay, and for example, topology is more general, okay. Now, group theory is also one of those things that, as you can see, a group is just it has very what you call this, the structure of a group is there are only a few requirements. So anything that you can say about a group will apply to so many things. Okay, so let's define what's a group. Actually, a group is something that you see what that you actually know, no, in everyday life, no? Except that you don't know that it's a group. So okay, so a group is a set, okay, and then it has an operation. It's an operation which takes two elements and produces another element, no? So for example, so in mathematics there can be different kinds of operations, no? So for example, the plus, the minus, no? They are operations. So one of the requirements of a set to be a group is that if you have any member of the group, and if you do an operation between them, okay, then the output should be another member of the group. No? So very good example of this is reproduction. No? So for example, humans form a group. In that sense, closure pala, closure. No? Because a human plus a human gives you another human. No? Or a cow reproduces another cow. No? So that's called closure property. Ito naman, associativity, it means that it has something to do with the order of the operations. No? So the order in which you do them. So for example, if you have three different elements and you do the operation on the first element and the second element, and the product of that, and the result of that, you apply it to the third element, it must be the same as you first do the first and second, the second and third, and then after that you multiply the first. Okay, so that's called associativity. Okay, so we know this from basic math, no? Okay, identity element, no? So the group must have an identity element, no? So which means that any member of the group multiplied by the identity element is equal to that member. No? So for example, if A is a member of the group G, and if you multiply the A with the identity element, no? Whether it is A dot E dot A or A dot E, it should give you A. Okay, so that's the identity element. Okay, and it should be unique. Okay, so notice that I'm talking about group in the abstract sense, no? So I'm not giving you any example at this point, no? I'm just talking about some group with some multiplication table that gives you the identity element. No? So a group doesn't necessarily need to be numbers. No? It can be anything. Okay. So the group also has an inverse element. No? So given any member of the group, let us say A, there is an element, let's say, which let's say B, so that when you multiply A and B, it will give you the identity element. Now, in other words, it will give B is the inverse of A. Okay. So if you have a set that follows these requirements, then you call that set a group. No? So a group is so simple. No? It only requires you to have this four requirements. Now, so you have a group G, no? And if you count the number of elements in G, the number of elements in G is called the order of the group. No? So it's another way of saying order is another way of saying that's the number of elements in the group now. Okay, so far, can you hear me?
Yes, sir. Yes, sir.
Yes, yes.
Hello. Very good.
Yes.
Okay. So I'll give you an example, guys, now. So the set of integers with group operation plus is a group. Okay? Kasi any two integers will give you an integer. Okay? So you add any two integer will give you an integer. Okay? And then we know that the integer follows the associative property. Okay? And then there is also an identity element, which is a 0. Okay, so if you add 0 to any integer, it will give you that integer. Okay, so for example, that one. Okay, and also the inverse of there's also an inverse element. No? So the inverse of A is just negative A, because if you add A with minus A, it will give you the identity element. So it's a group. Welcome, Burns. So I was just telling them about the power of group theory, you know, which is cuts across math and physics. No?
Yes.
Yeah. So this is an example of a group. No? So why is the group theory very powerful? It's because we only need these four things to be we only require these four things to be satisfied, no? And any theory you get out of this becomes very powerful because it applies to so many things. Okay. Okay. Now let us define the remainder. So there's a lot of fancy names now. or at the end of the day, we just want to make things simple. Huh? So when you say, if you have a letter, if you have a number A and a number big N, we define A modulo N to be the remainder that you get when you divide A by big N. Okay, so for example, what is 15 modulo 7? Okay, so what is the remainder when you divide 15 by 7? Okay, the answer is 1, no? Because 7
14.
times 2 is equal to 14,
14.
no? Pero 15
Remainder
kasi,
one.
so 15 modulo 7, the remainder is 1. So if you take a look at this, this is actually what I was saying earlier is this one. What I was saying is that 15 is equal to 7, 2 times 7 plus 1. Okay?
Yeah.
So itong 7, ito yung N mo. Okay? 15 is your A. And remainder is your 1. Okay? So that's the one. No? So modulo is defined also like that. No? So ang ibig, what it means is that A modulo N, A modulo N is the remainder. No? So it means that there is a number Q, which we don't care, such that if you multiply Q times N and you add the remainder R, it will give you the number A. Okay, so that's another way of saying the modulo of A modulo N. Okay, so let's save that. Okay, taking a look, it's already 6:37. Okay, guys, now this is really heavy stuff, no? So I hope you will bear with me. Okay, so now let G of N. Okay, so we are now talking about the set of numbers now. So let's now narrow our focus so that we are now talking about a set of numbers so that those numbers are less than a big number N and they have no factors in common. Okay, so imagine mo lang set of numbers now that are less than N. So I'll give you an example now. For example, 10. Okay, what are those numbers that are less than 10 that don't have a common factor? Okay, 1, 2 is not, 3, meron tayong 3, 4 is not, 5 is not, 6 is not, 7, okay, 8 is not, 9, okay. So itong mga to, we call this G of 10, okay. So these are the set of numbers less than 10 which don't have a common factor with 10, okay. Now it turns out that they form a group. They form a group with a multiplication modulo 10, okay. So there's an exercise here which says that show that it is a group. No, okay, we're not going to show that. Okay, let's just take it by faith. Okay, but there's it's not actually hard, but we will take more time. No? Okay, so let's save this and let's go to the next page. No? Now this is the most important thing, no? Because we are going to restrict our big N, our number, to be a prime number. Okay, so if it's a prime number, then what can you say? No? So for example, if we have 7, no? G7, what are the elements of G7? No? Elements of G7 are 1, okay? 2, 3, 4, 5, 6, okay? Because all of these numbers don't have anything in common with 7. That's why the prime number is really special, no? Because anything less than the prime number, no, between 1 and that prime number doesn't have anything in common, no? So what can you say, guys, no? The number of elements is equal to 7 minus 1, no? Is equal to 6. So in other words, if you have G of P, which is your group of numbers less than P, then the number of elements of that group is P minus 1. Okay? Same as this one, huh? 7 minus 1. Okay? In fact, I already showed you the answer to the exercise, no? Show that G of P has P minus 1 elements. Very simple, because for every element of G of P, since P is a prime number, everything between 1 and P minus 1 is an element, no? Ergo, there are P minus 1 elements. No? So the number of elements is called the order. Huh? Don't forget, this is called the order of the group. And this is very important, no? The order of the group. This is very important in understanding RSA. Okay, so let's save that. Let's go to the next page. Okay. Now, get any element of GP. No? So remember, guys, now GP is already the list set of numbers less than P, no? Where P is a prime number. Now, if no matter how many times you multiply A with itself, the product will never have anything in common with P. Tama? Okay. So now let K be a positive integer, no? Now, if you get A and you get the set, no? So from K equals 1, no? You generate the set of all yung ma-generate nito, no? The set of all numbers modulo n. It turns out that this set is also a subgroup of GP, no? Okay? Subgroup siya, ibig sabihin, it is also a group, no? It has the identity element, there's the inverse, and also anything that take any element of that set take any element of this set and then you multiply it with each other, the result will also be in that set, no? And it also satisfies the associative property. Okay, so that's why it's called a subgroup. Okay, now let us go here now. So I have here an example now. So take, for example, A is equal to 3, okay, and K is equal to 6. Now we can generate the members now. So 3 to the 6 modulo 7, okay. This will give you 3, 2, 6, 4, 5, 1. No? It turns out it's also the same as the set G of 7. No? Okay, and this is the multiplication table, no? The one that you see there. Okay, So let me give you another example. No? Okay. So hopefully you can see this. Okay, and I'm using R. No? R is a statistical software. So for example, 2 raised to the 2 raised to the 2, no? And then modulo 7 gives you 4, no? Now I want to generate everything, no? So for example, I want to create a sequence, no? X equals sequence of 1 to, for example, 6, no? So what I'll do is 2 raised to the x modulo 7. So as you can see, there are only 3 unique numbers, no? 2, 4, and 1. Okay, tapos paulit-ulit, no? Yeah, it repeats itself, no? 2, 4, and 1. So it means that the group generated by 2 modulo 7 is 2, 4, and 1, no? Okay. How about 6? No, what happens if we have 6? Okay. Okay. So it only generates 2. The group generated by 6 only generates 2 elements, no? 6 and 1. Okay. So that's an example of a subgroup, no? So the number of elements is called the order of this group, no? So every subgroup meron siyang order, no? Kasi group siya, no? Now meron tayong very important theorem which is called the Lagrange Theorem, no? What does this theorem say, no? This theorem says that if you have a group, okay, finite group, and you have subgroups, no? Imagine all subgroups of that group G, no? Imagine you can generate all subgroups. Now, for each subgroup, get the number of elements, no? Or the order. According to this theorem, okay, according to this theorem, the order of the subgroup will divide the order of the parent group, no? G. So ibig sabihin, G is divisible by the order of the subgroup, no? So for example, if the order of the subgroup is K, no? So get a subgroup, no? Any subgroup, count the number of elements, no? Let's say K. Now suppose the number of elements of the main group, okay, is P minus 1, or let's say let's talk in numbers na lang, no? For example, the order of the subgroup is of G is 6. Then and the order of the group is of G is 6, no? For example, guys, no? G of 7, yung kanyang order, okay? Yung kanyang order is 6, di ba? Now, earlier I showed you that the subgroup that was generated by 2, okay, which is generated by 2 raised to the k, the order of that, no, the number of elements is 3, di ba? So you can see that 6 divided by 3, 6 is divisible by 3, no? So that's what this theory is saying, no? Okay, so that's what this theory is saying, no? Now this is very important, no? In understanding the RSA. Okay. Now there's an exercise here. It says that, are you sure that you can get that you have a number K, so that when you raise the number A raised to the K modulo N, it will give you a remainder of 1. Okay, this is how you show it, no? yeah, so how you show it is that, okay, I don't know how to remove this thing here, no? Pero it's blocking the way, you know. But anyway, according to this one, can I, okay, okay, can actually drag it. So it's very simple, no? If you have two numbers m and n, and then you get the power of raise a to the power m, and suppose they're equal, no? Suppose they're equal. Then what you do is, because this is a group, no? Because the group has an inverse, which means that you can multiply both sides by a to the minus 1, no? The inverse of a to the n. Because it's an inverse, what it means is that this one becomes 1, okay? And by the law of exponents, guys, no? I hope you still remember the law of exponents, no? The law of exponents means that if you multiply a to the m with a to the minus n, what you can do is just raise a, and then you add the exponents, no? That's the law of exponents, okay? So now if you define this to be your k, then you have just shown that a to the k, that you have a k, so that if you raise this to the k, it will give you 1, okay? So that's what this exercise is saying, okay? Save that. Let's go to the other one. Now, so earlier we were talking about generating a group. Now you have a, and then you have k, and then you generate the elements. Now the smallest such k, so that a to the k is equal to 1, is called your order. No, it's called the order of a. No? So the smallest such k, okay, smallest such k, that's called the order. Okay? Order. Okay. So for example, let me show you. Okay. We have 6, no? 6 raised to the x, no? Where x is equal to this, no? So we generate, no? So that our notation is consistent, no? Let me just say that k is equal to x, no? So that a raised to the k, a raised to the k. Okay, I hope you can see this. If you're not, then I will try to make it bigger, no? So a to the k percent or modulo 7. Okay. What did I say? A. What happened to my A? Okay. A, sorry. 2 to the k pala, no? 2 to raise to the k. 2 raised to the k percent 7. No? Okay. So as you can see, what is the smallest number which will generate all groups, no? All elements? It's 3, no? Smallest number 3, because you have 3 elements, no? So 2 to the 1, 2 to the 2, 2 to the 3, no? It will give you 2, 4, 1. Order of the, so in other words, the set generated by 2 raised to the k, which is equal to 2, 4, 1, okay? So k is equal to 3, no? Which is the order of the group, no? The order of the group. Okay. Now, so order is very important, no? So in view of the theorem of Lagrange, no? And the equation above, we can show that a raised to the p minus 1 is actually equal to 1, no? So if you raise a to the p minus 1, get the remainder, no? Divided by p, get remainder, the answer is 1. And how do you show that? No? So this is the these are the steps, no? Okay, so so first you have you're given that a to the k, so k is the order guys, now. So when since k is the order, which means this is this thing here is true, no? Now, since 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 the group generated by a to the k, no, is a subgroup, it means that the order, which is k, divides p minus 1, no, according to Lagrange theorem. No? So according to Lagrange theorem, this one is true. No? So what does that mean? What does that mean that k divides p minus 1? It only means that p minus 1 is equal to some integer which we don't care times k. Okay? So that is what it means. So in other words, if that's the case, then a to the p minus 1 is equal to a raised to the mk, no? Now, because of the law of exponents, we can just you can permute this, diba? So pwedeng baliktarin to, no? So which means this can be a to the k raised to the m, no? But since a to the k is equal to 1, therefore a to the p minus 1 is equal to 1. Okay, so this kind of mechanism to show something is, we will use this a lot of times, no, in the RSA theory. Okay, so just remember this. No? Just remember how we did this. Okay, now let's go to the next page. Show that if a is equal to 1 modulo n, then if you raise this to the power k, if you raise a to the power k, you will always get a remainder 1. No? And this is how you show it. No? It's very easy. You will just need to, for example, show that it is true for when you square it. No? So when you square it, you get this, no? You get this expansion. No? You square it, and then you just get the, just factor out n. This one is of this form, no? Because this one is of this form, then you can say that a squared is equal to 1 modulo n. And then the same goes for a cubed, no? So the hint here is use the binomial theorem. Okay, so that's the thing. Okay, next. Okay, so we are now going to the main thing, no? That is going to show Shor's algorithm, the RSA theory. So suppose we have a number, let's call it a, no? And then this number is not divisible by a prime number, no? So let's have a number a that is neither divisible by prime numbers p and q. Okay. Now, so no matter how many times you multiply a to itself, the product will never be divisible by p or q. Okay, because p and q are prime numbers. Okay, and because p and q are prime numbers, it means that a and all powers of a don't have an element that is common to p. So what do we call that set? It's called G of p, no? Sorry, how do I, okay. So this one here, G of p, no? So G of p is the set of all numbers that don't have any common common factor with p. And in the same way, because our number a is also not divisible by q, and q is a prime number, okay, it means that a and all of its powers does not have a common factor with q, and because of that, they are A and all of its powers is an element of GQ. Okay. Now we have shown that any number, A, any power of A is an element of GP. Okay. Then it follows that A, this one here, which is a special number for us, is also an element of GP. Okay, so in other words, it doesn't have a common factor with P. Okay, so sabi dito, if we substitute A with this one, okay, let's go to equation 2. Sorry, let's go to equation 2. Okay. Okay. Remember equation 2? A raised to the P minus 1 is equal to 1. What we will do is we substitute here A raised to the Q minus 1. Okay. So this becomes A raised to the Q minus 1 raised to the P minus 1 is equal to 1 modulo P. Okay? Simple, no? Okay? So, let's go back here. Oh, I was just telling you this, no? That I don't know what happened here. Okay. I was just telling you that, no? Okay. So, now in the same way, no? In the same reasoning, we can say that any powers of A is an element of GQ, and in particular, we have this one here, P minus 1, A to the P minus 1 is an element of GQ. That's why we have mod Q here. Okay, so A to the P minus 1. So using equation 2 again. Okay, so let me write equation 2. Okay, so equation 2 means that okay, I don't know why. Okay, so equation 2 is A raised to the P minus 1 is equal to 1 mod P, diba? Mod P. Okay, so in the same way, A raised to the Q minus 1 is equal to 1 mod Q. Okay, now according to equation number 5, we have, since A to the any power of A is a member of GQ, which means that if we substitute here A to the P minus 1, then we get A to the P minus 1, okay, raised to the Q minus 1 is equal to 1, no? Mod Q. Okay, so ganun siya, no? Okay, so we now have two equations now. We now have two equations, 4 and 5. Okay. Okay, guys, so far so good. Are you still able to follow?
Yes, sir.
Okay, very good. Okay, just you can interrupt me anytime now, because I know that you are not rude. Okay, so what does the two equations mean, no? So the two equation, what do they mean, no? Okay, if we go back here, okay, if we go back here, no, the first equation, number 4, it means that if you what you call this, if you so this one kasi, no, this one, so remember, no, we can write this as okay, I don't know, if you transpose kasi the 1 to the left side, it means that this quantity, a to the q minus 1 raised to the p minus 1 minus 1 is divisible by p. Okay, so I wanted to show that, but I cannot write now. So let me, okay, let me write it here now. Okay, let me change it to blue. Okay, okay. Apply new parameters. Okay, okay. So let me just show you guys now. So, remember that we have this definition of modulo, diba? So when we say a mod n, okay, when we say this actually means that a is equal to some number q, which is called the that one is confusing, no? Some number s na lang, no? Multiplied by n plus a remainder, diba? So this one is the modulo, diba? Okay. Now this one is also modulo, diba? This one that you see here, that's modulo, diba? So you can also write it as like this, no? A q minus 1 raised to the p minus 1 is equal to some number, let us say s, multiplied by p, okay, because this is mod p, okay, plus the remainder is equal to 1, diba? Now if we transpose 1 to the left side, this becomes a raised to the q minus 1 raised to the p minus 1 minus 1 is equal to sp, diba? Okay, klaro yan, diba?
Yes, sir.
Okay. Yes.
Yes, sir.
Do you have a question? Sure. Do you have a question?
No, sir. No, sir. All good, sir.
Okay, so okay, so that's good, no? The feedback. Thank you. So what does this mean, guys? No, what does this mean? This means that the left-hand side, no. Let me just. This means that make this red. No? What? Ginawa ko ng blue. Eh. So this means that this thing here, okay, okay, tingnan mo yan, ha? This thing here is divisible by p. Okay, why? Why is this thing divisible by p? Because this thing is nothing but sp. Okay, this thing is equal to sp. Since sp is a product of s and p, it means that it's divisible by p, no? Okay, so which means you can divide it evenly, no, without any remainder. Okay, so this one is divisible by p. Okay, now guys, no, we also know that if you take a look at this equation number 5, you can also write equation number 5 like this, no? Equation number 5 is like this. Where do I put this? Okay, equation number 5 is like this, no? It's actually similar, no? Similar siya, no? Except that p becomes this one here. Equation number 5 is actually equivalent to a raised to the p minus 1 raised to the q minus 1 minus 1 is equal to s times q, where s is, sabihin na lang natin na instead na saying s, no, l, okay, l times q, no. L is, we don't care, no, it's a number, it's a whole number. Okay, what we're saying here is that this thing here is divisible by q. Okay, so this thing here is divisible by q, but this thing and this thing are the same. Okay? So what does that mean? It means that this thing is divisible by both P and Q. Okay? In other words, they're divisible by P times Q. Okay? So that's what this one is saying. Okay?
Let's see. Yes,
So
sir.
it's divisible by P times Q. That's why, since it is divisible by P times Q, this first equation means that okay, balik tayo ha. The left hand side, okay, take a look at this blue thing here. Okay, this is nothing but the left hand side of this next page. Okay, left hand side equals M times PQ. Okay, where M, we don't care what M is. Okay, because this one is divisible by P times Q, it means there must be some number M, which we call it M, multiplied by PQ, so that this one here is equal to this. Okay. However, if we transpose one to the other side, you get this very familiar looking equation. No? What is this equation? Familiar looking equation. This is nothing but the definition of the modulo. Okay. So A raised to the P minus 1 times Q minus 1 is equal to 1, no? The remainder, mod PQ. Okay. Now, that one is, so you might be wondering, where is all of this leading, no? Okay, just relax, no? We're going to go there, no? Okay, just remember this equation here, okay? This one here, okay? Now, okay, from exercise 6, okay? If S is a positive integer, we can raise equation 6 to S, no? So what is exercise 6, no? Balikan natin, no? Let's go back, no? What is exercise 6? Okay, what is exercise 6? Okay, guys, this is just exercise 6, okay? Okay, sorry. This one, okay? So it means any number, if it means that if A is equal to 1 modulo N, then you can raise it to any K and still get the remainder equal to 1, okay? So in other words, since this one is equal to 1, okay, since this one is equal to 1, then we can raise it to the power S, no? Where S we don't care as long as it's any number, okay? Okay, so if we raise it to the power S, you get this, okay? You get this, yeah, okay? Now, by the law of exponents, multiply both sides by A, okay? Okay, guys, this is already the exciting stuff, huh? Because this one is already showing you, the RSA, no? Okay, so mamaya makikita niyo, no? Now, if you multiply both sides by A, okay, then you will get this, okay? You will get this. Okay, so this becomes A raised to the S. Okay, by the law of exponents, guys, no? Please don't forget, no? Law of exponents. What does the law of exponents say? Okay, so law of exponents, if you have, we have 7 raised to the 2 times 7 raised to the 3 is equal to 7 raised to the 5, diba? Okay. Yan din yun, no? That's the same thing, no? This is the same thing because, for example, A, okay, 7 times 7 cubed is equal to 7 to the 4th, no? So in other words, we just add +1 here, okay? That's where you get the +1, okay? The +1 actually came from A, okay? Now, look at this, guys, now. This is very important, that equation there. Okay. Okay. This one will answer. This one will answer the question, why is it that we are what we are going to do now is actually deriving the private key. Okay, this page here tells you how to derive the private key. Okay, explains to you. Okay, so yung C natin is the coding number, di ba? This is the number which we given a message, we raise the message to the power C and get the modulo of that with respect to P times Q, and the remainder is the encrypted text, diba? So remember C, no? C is your coding number, no? C. Okay. Now C is very special, no? Why? Because we take it from another group of elements, no? Another group, which is the group of this one here. Okay, this group. Okay, C is an element of that group. Okay, so that's why P and Q, which is the factors of n, you know, they are very important, but they're also very hard to compute, no? But once you compute it, then you can get the inverse, no, of C. So now since this group, since this one is a group, now since this one is a group, I'm emphasizing that it's a group, no? Why? Because it is a group and C is a member of that group. What does it mean? It means that C has an inverse. Okay, that's why it's very important that it's a group, so that we know that C has an inverse. Otherwise, if it's not a group, we cannot say that it has an inverse. Okay, and the whole RSA will collapse. No? So that's why it's important to realize that this one is a group. Okay, so this one is a group. And because it's a group and C is a member of that group, then it has an inverse D. Okay, by definition, an inverse is if you multiply the inverse by C, D by C, it will give you 1, no? Modulo P minus 1, Q minus 1. Okay, hindi modulo P times Q. Okay, it's modulo P minus 1, Q minus 1. Okay, but guys, take a look. What does this mean? What does this mean? Okay, it means there is an S, which we don't care, no? Such that if you multiply S by this one, okay, plus the remainder, it will give you CD. Okay, so let me refresh your memory again by the definition of modulo, no? So by definition of modulo, A is equal to S times N plus remainder, no? So yun ibig sabihin yan, no? So ibig sabihin, A is equal to R modulo N. Okay? So ano yung N natin dito, no? Is P minus 1, Q minus 1, no? And ano yung R natin, which is 1. Okay? So ano yung A natin? Yung A natin is CD. Okay? Yung S natin is the same, no? Now take a look at this. Okay, take a look. This is very important. Okay, you stare for a moment at this equation. Okay, CD equals S P minus 1 times Q minus 1 plus 1. Okay, stare for a moment. Put it into your memory, and then take a look at the other. Let's take a look at the previous slide. Okay. Okay. Take a look at the right side, guys. No, and the left side. If you go back, save. If you go back to the Okay, so this one is the right hand side is actually just the exponent, okay, of A. So S P minus 1 Q minus 1 plus 1 is actually equal to C times D, okay, according to this. Therefore, A raised to the C times D is equal to A, okay. Okay, take a look. Let me, oh, I cannot write now. So big, so equation 8 combined with this equation will give you equation 9. Okay. Okay. So in other words, A raised to the CD is equal to A. Oh guys, obvious na ba? That's already your decryption. Okay. It's already your decryption. Okay. Kung hindi pa obvious, let's take a look. So if your message is, if your plain text is A and C is your coding number, then to encrypt it, you do this. Okay, you do this, diba? But if you have letter D, which is the private key, then equation 9 tells us that A raised to the D is nothing but A to the C raised to the D. Okay, but A to the C is nothing but B. So B to the D is equal to A. So ito yun guys, no? This is the foundation of RSA, no? So it tells you why RSA works, no? It tells you why the private key is able to decrypt your ciphertext, no? So this one is your encrypted text, no? So your encrypted text raised to the D, where D is the private key, will give you the original message. Okay? So that's the magic of RSA. Okay? And we were able to show that using the power of group theory. Okay? So that's the RSA, guys. No? Okay, what time is it? Oh no, 7:23. Okay. So, konti na lang, no? Just a few more, and then we'll wrap up. No? What I'm now going to show you is you are a hacker, no? You're a cracker. You don't have access to the private key. Okay? So what can you do? Well, because of period finding, if you know the period, then you can also decrypt it, no? And we will show that mathematically. Okay, go. Let's review the period, no? So if you are given an encrypted message B, cancel. I don't know what. Okay, B is your encrypted message. Now, if you, the period R is that number, the smallest integer, so that when you raise B to the R, it will give you 1, okay, remainder 1, okay. So this is the definition of the period, okay. So why is that very important? Okay, let's go to the next page. No? So again, no, you have a plain text A. If you want to encrypt it, you raise it to the power C mod PQ to get B, okay, that one. Now guys, this is very important. It turns out that the period of B is the same as the period of A. Okay, take a look. Okay, so the period of B is the same as the period of A. No? So how do we show that? No, how do we show that? Okay, let's show that by this one here. So we know that this is true, okay? Why? By definition of the period, okay? We know that that's true, okay? Now, since B is our ciphertext and B is equal to A to the C, we then have this, huh? If you raise both sides to the R, it will give you A to the C, huh? The R. Now, you just have to baliktad the exponents now. Commute, no? The exponents, commutative property. No? Now it becomes A to the R. No? But we know that A to the R is equal to 1. So which means that B to the R is equal to 1. Okay? Okay. So that's this is an important property. Okay. Okay, guys. Now this one here, the next page is quite a mouthful, no? Pero let's do it step by step now. Okay, so we know that C is an element of GP minus 1, Q minus 1. Huh? And we know that the period R divides the order of GPQ by the Lagrange Theorem. No? So what is the order of this group? Okay, what is the order of this group? The order of this group is nothing but P minus 1, Q minus 1. Okay? So it means that because C is an element of GP minus 1, Q minus 1, it means that C does not have a common factor with and R, okay? R divides the order of GP. It means that C does not have a common factor with R. No? That is, C is an element of GR. Okay, it's very important. No? C is an element of GR. No? GR is the set of numbers less than R that does not have a common factor with R. Okay, that's the definition. And C is an element. No? Now, since GR is a group, there is an inverse. Okay, since this one is a group, then C has an inverse. No? And we call this inverse D prime. Okay. Okay, guys. Now, ngayon, let me explain. No? Why is it that C does not have a common factor with R? No? Okay. Why is it that C does not have a common factor with R? Because of this, no? Because R is an order and is an order of the subgroup. And by the Lagrange theorem, any subgroup get the order of that subgroup, and call it R. It divides the order of the bigger group. Okay, and the bigger group is P minus has elements equal to the number of elements equal to P minus 1 times Q minus 1. Okay. So ibig sabihin yan, since R is a divisor, then there must be a number X. We don't care what that number is, but we know that there is a number X, so that if you multiply X times R, it will give you P minus 1 times Q minus 1. Okay? Okay. So, since so what are we trying to show here? We're trying to show that C does not have a common factor with R, diba? So that's what we're trying to show. Okay. Now, since C is a member of this group, okay, what does being a member of that group mean? If you are a member of that group, then it means that you don't have a common factor with P minus 1 times Q minus 1. Okay? Ergo, since P minus 1 times Q minus 1 is equal to R times X. Okay? Therefore, C does not have a common factor with R. Okay, so C does not have a common factor with R. And what does that mean? If C does not have a common factor with R, it means that C is a member of GR. Okay. Okay. So yun lang yun. No? So C is a member of GR. And because of that, and since GR is a group, then C has a inverse. And this inverse turns out to be very important, guys. No? Why? Because this inverse turns out to be the one that will decrypt your ciphertext. Okay? So if you raise the ciphertext mod PQ to the power D, we have this, no? B raised to the D is equal to AC raised to the D prime. But CD prime, guys, what is CD prime, no? What is CD prime? Ito yun, CD prime, okay? That one here, CD prime, is equal to 1, okay? So CD prime well, CD prime is equal to 1, which means that A to the 1 is equal to A. Pero there's another derivation. Huh? Since CD prime, so CD prime is equal to 1. It means that so CD prime equal to 1 means that there is an M which we don't care, so that CD prime is equal to M multiplied by R ito mod R to ha, mod R. Okay. CD prime is equal to MR plus 1. Okay. So this is the one that we substitute in here. Okay. Now this is nothing but by the law of exponents, A times A to the RM. But R, A to the R is equal to 1. Okay. Because this is the period. So that's why B to the D prime is equal to A. Okay. So B to the D prime is actually equal to A. Okay. So in other words, we have just demonstrated that even without the private key, if you are able to get the period, then you can still decrypt the encrypted text. And that's the end of the session, guys. Any questions?
Yes, 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 yes. Question. Hello?
I cannot hear you clearly.
Hello? Hello? Lalakas ang ulan. Hold on.
So,
Hello?
umulan. Ay,
Hello?
oo nga, no? Umulan
Ang
nga
lakas,
pala.
ang lakas ng ulan. Ang lakas
Okay.
dito ng ulan sa akin. Hold on.
Oh. Sige,
Sir,
Ron, what's your question?
yeah, actually, my interest peak again. Sorry,
That's
sorry. Sorry. Actually, it's a, I don't, this is recorded, right?
Yes.
I don't want to put you on the spot, but is this, you're talking about this process, you're talking about only applicable for ciphertext, like sending a message to another person? Because if you're talking
Applicable
about,
lang, yeah. This one is only applicable to RSA encryption.
I mean, sir, yeah, RSA encryption, but is this only applicable, for example, if I want to send a personal message to you,
Yes.
is that, it's just this what do you call this RSA only applicable for sending messages, not
Sending and decrypting. So for
sending
example, but I'm the only one who can decrypt.
yeah.
Everyone else in the world can encrypt.
But my biggest question here is this also applicable? Like for example, there are lots of kinds of hacking, like sending message in an email. For example, I sent you an email, and then suddenly I programmed that email to open you up, to hack you. And it contains metadata like pictures, sounds, or even attacking code that can put me on a root directory for overall general privileges to really look into you overall. Is this also applicable to that? I'm not putting you on the spot.
No, no.
Parang,
That's
parang
a different.
applicable.
That's a
Uh,
different. That's a different thing, Ron. Iba yan. Yeah,
okay.
iba yan. That's what do you call that? That's planting a malware or a virus into someone
Yeah.
else's computer. Yeah.
Spyware,
This
yeah.
yeah, this one is just for communication, for encryption, secure
So
communication.
parang ano lang to, parang sending message in the messenger on the text or parang ganun
Yes.
lang siya.
Yeah, yeah. Oh, yeah. Okay. That's good, no? That you said that, no?
Kasi,
For example, there are some applications that tell you, no, that they have end-to-end encryption, no? End-to-end
yeah,
encryption. What does that mean, no? It means that when these two, for example, if you WhatsApp me, no,
oh yeah,
WhatsApp said that they have end-to-end encryption. What does that mean? It means that there is a when you message me, WhatsApp is going to get my public key.
public, yeah,
Yeah, and then when you type your text and then you hit send, what happens is that the message will be encrypted using my public key, and then it's sent to the wild, no, to the internet, where
yeah,
anyone can listen. But since I'm the only one who has the private key, I am the only one who can decrypt it.
yeah, that's true.
Yeah, yeah, and that's the application of this.
Also, I hope you still have time. But another question, based on this you presented, especially with RSA, it's like doing a blockchain. Because if you open up, cryptocurrency account, I think Asher can relate to this. If you open a cryptocurrency account, you need a hot wallet and a cold wallet. And in order for other people can transfer you money, is you have to give them your public key, and
Okay.
you have to keep your private key. So
Yes.
that private key that you're keeping on transactions, especially with cryptocurrency and blockchain,
Yes.
um, the only way to connect to your private key is your public key. Public key is the one who is exposed to other people
Yes.
for you to
Tama ka,
receive.
Ron. Tama ka.
It's the same.
Yes, the
It's the
same.
same. The
But the
same pa. Okay.
algorithm is different lang. It's using it's
Uh,
using
and
it's using elliptic curve. Pero we are going to take to also talk about elliptic curve. Kaya okay lang.
hold on.
Yeah, it's the same.
Another one is they call it in blockchain. It's SHA-256. Is
Yes, yes.
that right?
Uh, SHA 256.
Yeah, it's SHA-256 because that's the only one. That's the only encryption that the blockchain is really recommending or recognizing. That's why I'm sorry na-ask ko lang kasi nag-pick sa akin bakit parang ciphertext lang. Is it possible meron pa ba yung, for example, like yung binanggit ko kanina? Because there's a million ways how to attack and how to hack.
Oh,
So ciphertext
this
lang
one
pala
is
to.
just this one is just communication.
Okay. Yun lang yan. Sorry
Oo.
kung masyadong mabigat yung tinanong ko or something
Okay lang
like
yan.
that.
Okay lang yan. Mm.
Uh,
Okay. Any other question?
yun lang yung sa akin.
Okay. So guys, so finally, let's let's go back to um our objective now when we started, no? So our objective when we started is this, no? Uh sorry. So objective when we started, no? So we wanted to explain why is D able to decrypt the cybertext, no? So we were able to explain that, no? So why is it that we use P minus one, Q minus one, no? Why do we compute the why do we compute D using the modulo P minus one, Q minus one, and not PQ, no? So guys, this is very important now. Remember that PQ is public. Okay, public yan. Now, to get P minus 1 times Q minus 1, you need to get P times P and Q, di ba? But P times Q, which is your public key, is very hard to factor. No? To factor N to P times Q is, yun nga, takes 300 trillion years, no, for a 2048-bit encryption. Okay? Kasi if ever you are able to factor P N to be P times Q, then it's just peanuts to get P times P minus 1 times Q minus 1. And once you get that, you're able to compute for D. And now you have the private key. No? Okay. Now, we have another route. No? What we're doing in Shor's algorithm is actually computing the period. No? And when we get the period, this is the base of our modulo. No? So given the coding number, we get the inverse of the coding number, modulo R, and that is D prime. And we have shown also that it can decrypt the ciphertext. So now, hopefully, when you review this video, you will get to understand more the mathematics behind the RSA. Okay, and that's good because I mean it's good. Okay, so any more questions?
Sir, just one last question.
Yes.
This is representation of mathematics of what do you call this? This RSA, right? This RSA encryption and decryption.
Yes.
Is this mathematics, can you convert it into programming to real, like for example, a software like or an app like WhatsApp?
Yeah. Yes.
Oh, but,
In fact, yung exercise, diba, the exercise that I gave you, exercise
Yeah.
number 1,
yeah,
which Asher as a what you call this, a video.
yeah.
It actually asks you to program it.
Yeah, I know it's the for
Yeah.
loop and the
Yes.
if
Yes.
the if statement. I saw the Python
Yun.
programming. Yeah. So when you create an app like WhatsApp, Messenger, you're using the same mathematics. It's just so happens.
Yes. Yeah. The
Just
underlying mathematics is the
oh,
same. Yes.
so the only difference is you have to program it. That's another thing.
Well, right now, kasi it's you just use libraries. No, you don't need to program it. The only reason why I asked you to program it is so that you will learn how it's done.
Yeah.
But after that, you can just use
Just
libraries
mathematics.
to But the basis of all of this is mathematics. No? Yeah,
Yeah, that's all.
power. Yeah.
Thank you.
Okay, so any more questions? Yeah, because I have a meeting at 8. Yeah, so I think that's it. Let me see who attended. So we have your Burns, Brian, Ron, Sure. So thank you very much, guys, for attending. Yeah, so these are the kind of things that we are going to discuss now. So quantum computing is just a small part, no, of a very big thing. No? Quantum computing is, you can treat this a black box, no. But if you don't know anything about this, no, about formulating your problem, about about for example, formulating optimization problems, no? um, you can forget about quantum computing because it will not help you. No? So that's why we focus on the other side of quantum computing, which is this one. Okay, what are we trying to solve? That is actually the more important one, because quantum computing in the future will just be a black box to us. Okay, it's just gonna be a. So this is actually the important to know all these things, and it's good, no? Because when we talk about these things, it actually allows the members of our group to no, to expand their awareness, no? About things. No, we covered group theory here. No, group theory I mentioned earlier is very much used in physics. No, that's what you use to predict the quarks. No, group theory. And now we showed group theory applied here in RSA. No? So there are a lot of things we are going to learn. No, traveling salesman, we are going to also tackle that. No, optimization problems, which are actually one of the is very important in quantum computing, because optimization has a lot of uh, applications, no? So it's applied to machine learning. No? So that's it, no? So thank you, guys, and yeah,